So continuing on here, we're trying to find out when the function is increasing. So when our function is increasing, that means that our derivative function is greater than 0. And so what we did here is we chose our critical points where we know our derivative equals 0. And those are the only points that it's going to equal 0. And then we look to the left and right of those points to determine what the sign was of the derivative function to the left and right. So we know that, for x going from negative infinity to negative 5, we had a positive derivative function, which meant our function was increasing. Where else is it positive? It's also positive union negative 1 to 2, and from 2 to infinity. Not including 2, because at 2 the slope is 0, so it's neither increasing nor decreasing. Let's just look at this one more time, though, using different numbers. What we did is we said, given x and f prime of x, we know that at negative 5, our derivative is 0. At negative 1, our derivative is 0. And at 2, our derivative is 0. So those are the only points that my derivative is going to be 0. And but what might be even more helpful than this picture that I've drawn up here is for us to graph f prime of x. So what if we graphed f prime of x? Knowing what we know about a factored polynomial, here we have negative 5, negative 1, and 2. And we know that at negative 5 it equals 0. At negative 1 it equals 0. At 2 it equals 0. We know that this function is a fourth degree with a leading coefficient of 1, which is positive. So we know it's going to look something like this. We know it's going to bounce at x equals 2 because of the multiplicity. So our graph is going to look something like that. And this is the graph of f prime of x. So if we want to know, for what values is f of x increasing, f of x is increasing when f prime of x is greater than 0. Well, where does that happen? Let me show that in red. That happens here, here, and there. So for what values is the original function increasing? The original function is increasing for x being from negative infinity to negative 5, from negative 1 to 2, and from 2 onwards. I think that's probably a more helpful way to look at it, just looking at the graph. But the table chart is also helpful, because we know that for x being less than negative 5, choose any number, negative 10. Our derivative function is positive. X being between negative 5 and 1, negative 1, choose any number. We're going to result in a negative. Between negative 1 and 2, we have a positive slope. And from 2 onwards, just choose any number and plug it into the function. It's going to be positive as well. The table thing, we will use that a lot later on, but I think for now the graphical examination might be more helpful for you. So when is the slope of f of x increasing? Answering C. Well, let's put this graph of f prime of x up again, because I think it's going to be helpful in answering this. So we've got negative 5, negative 1, and 2. And we know that our graph looks something like this. And we're going to answer when is the slope of f of x increasing. Well, the slope of f of x is f prime of x. So this is really asking, when is f prime of x increasing? Well, f prime of x is increasing. Graphically, let's show it. It's increasing from during the green sections. That's when it's getting bigger and bigger and bigger. That's when it's going up, left to right. So there are my signs of it increasing. So what are those values? Well, estimating it roughly. So this is between -5 and -1, -3. So it's increasing. The slope of f of x is increasing, or f prime of x is increasing, for x being between the values -3 up until this point here. We're going to have to approximate that. It's roughly 0.5. Just looking halfway between those points. And then from 2 onwards. So tying this all together, to get a graph of f of x, we know that f of x is going to be increasing for -infinity up into -5, from -1 to 2, and from 2 to infinity. We know that there's going to be critical points at -5, -1, and 2, where x equals those. And we know that the slope is going to be increasing for these points. And for the slope to be increasing, for f prime of x to be increasing, or the slope to be slope of f of x to be increasing, we know that that means it's going to be concave up. What else do we know? What about local max? Local max is where my function, local max is where the derivative of x goes from positive to 0 to negative. And that's occurring right here. So we know that there's going to be a local max at x equals -5. And we know that there's going to be a local min when the derivative function goes -0 to positive, and that occurs right there. So there's going to be a local min at x equals -1. So now we can start piecing this together. Just drawing a rough sketch of this. We've got -5, -1, and 2. We know that there's a local max at -5, so let's just draw in a local max. And there's a local min at x equals -1, so let's just draw in local min. We know that the slope is increasing from -3 to 0.5, so that means that it's concave up from -3 to 0.5. So concave up from -3 to 0.5. And it's also concave up from 2 to infinity. So therefore, from in between 0.5 and 2, the slope is decreasing. Since it's not increasing, so we're going to have a decreasing slope until 2, and then it starts increasing again. And now looking at the left-hand side, we have the following. So connecting the piece, right in here. There we go. So connecting the piece between that little gap here, it's going concave up. We have that local max that we talked about right here, the local max. So the local max. And then from -5 towards -infinity, my function is positive during that whole time. This whole section, my function is positive, so it's just going to go down like that. So we get this function that has a positive slope, local max. At this point, we go from being concave down to concave up. So now we're concave up, and then we're concave down again, and now we're concave up again. Take some time to digest that. This is some tricky stuff, but what we did is we sketched a possible graph of f of x given this rather challenging polynomial of the derivative. Looking at another problem, we've got the derivative function again, and we want to figure out the critical numbers. So the first thing we need to notice, well, they both share an e to the 2x, and just as a reminder, e to the 2x looks something like that. So what we can do is we can factor out an e to the 2x and an x, because they both share an x. And what we have left off with is x plus 2. And we want to find the critical numbers. So the critical numbers are when f prime of x equals 0. Well, we have three factors: factor 1, factor 2, factor 3. We know that e to the 2x is greater than 0 always. It can't be 0. So this factor will never be 0. So the only ways that my derivative function can be 0 is either when x equals 0 or when x plus 2 equals 0. So when x equals 0 or when x equals negative 2. So here are my critical numbers. And we want to know, so we found the critical numbers. The next thing we want to find is, for what values is the original function of f of x increasing? So if f of x is increasing, what that means, what you need to start understanding, interpreting, f of x increasing means that f prime of x, the derivative, is greater than 0. Because remember, for us to say that the derivative of x is greater than 0, that means I have positive slopes. And if I have positive slopes, these are all examples of positive slopes, my function must be increasing. Okay, so when is this increasing? Well, let's think about it. We've got rewriting f prime of x, and I'm going to write it as e to the 2x times x to the x plus 2. And I'm writing it like this because this portion is always positive. So we can kind of ignore it. It's always positive. But if we look at that and make a sketch of it, f prime of x, and we know that it's going to have zeros at x equals 0 and x equals negative 2. And we know that it's a quadratic with a leading coefficient that's positive, so it's going to look something like this. So right now, all I'm graphing is this piece right here. Because all I'm looking for is when is my derivative function positive. And I can ignore this piece here because that's always positive. So the only thing that's going to affect positive or negative is this right-hand piece. And by graphing it and inspection, we know that for x being between negative infinity, negative 2, or 0 to infinity, for that values, f prime of x is going to be greater than 0, which means that f of x is increasing. So for what values, to answer question B, for what values is the original function increasing? It's increasing for these values of x. Now that's some sophisticated math that we just did, so it might be worth rewinding this and looking at this sheet just one more time.